Windows Server 2022, welcome back everybody. I'm Prakash Pradhan, your trainer for this entire series. In today's topic, we're going to talk about software-defined networking. So let's understand first, what is this software-defined networking? Why do you need to know about it? Okay, where do you think this can be implemented? Now, how do you think this SDN is going to help you in order to perform your day-to-day life activities in the world of your routing? Okay, now before we go into deep for the discussion of this SDN, I would like to take you to the simple tool so that you get it clear picture. If you have a look over here, okay, if you have a look over here in this figure, so let's say there is a one car, okay, over here, this car, let's say for example, this car's driver is willing to go somewhere, anywhere. It might be this direction, it might be this direction, it might be this, or it might be this. Okay, now if this driver doesn't know about the proper location actually through which road he or she is supposed to go, you might be thinking Google Map. Okay, that is a one option. Let's say that this guy doesn't know about that. In that case, there is only one way. Might be asking straight away to the traffic police over here, asking about the particular address through which road he or she is supposed to go. That means this user is depending on this traffic police about the particular address direction actually through which road he or she is supposed to drive. Similarly, other drivers over here, whoever are driving a car, they also depend on this if there is no proper guideline. It's a human nature that if we are not aware of any direction or the map, definitely we are going to ask to anyone. That means all of these drivers must be depending on this, hoping that this driver or this traffic police knows the proper road through which he or she is supposed to move from here in order to reach to their destination. Here's the one thing now. Any driver, whoever is driving a car over here, need to know actually the proper direction before he or she reaches to the destination. But it is not sure that this traffic police knows through which road this driver is supposed to be directed actually. This might be knowing only one or two addresses. So in that case, if this driver asks a particular address to this traffic police, okay, if doesn't know the particular location, in that case, this traffic police might be asking for help to someone else who might be having somewhere with the help of the wireless connection. It might be with the help of the walkie-talkie. That means one thing is sure over here. The one whom everyone is asking for the help might not know the route path of all the direction. This is the common sense. So when we talk about this SDN, exact things are going around actually. Software defined networking, how it works, okay, let's start from this figure. If this is the source computer, okay, asking or trying to reach to any web server, any server, okay, that server might be located over here somewhere in some corner of the world. In that case, the first request that is coming out of this PC or the workstation will definitely go to the router. It will ask to a router that I need to go to so and so website because the internet connection is done via your router. So in that case, it's not sure that this router knows the exact way, exact path through which this router is supposed to take you to that particular website. So in that case, what's going to happen? I do believe you all know about this networking. This router has a routing table now. If this router is not able to know straight away that particular address, this router is going to ask for the information to the next hub connected to it. That means this router has a routing table and this router also has a connection to the nearest next router. So now this router is going to ask to this router and this router is also trying to make a request to the right hand side router because they all have a routing protocol. Okay, and they all have a proper information of each other. They might be knowing the routing table of this router also. This router might be knowing the routing table of this. This router might be knowing the routing table of this. Similarly, this router also might be knowing the routing table of this because they used to share the routing table with the help of the routing protocol. Routing protocol, it might be your OSPF, it might be your EIGRP, IGRP. It can be any type of your protocol in order to share the information of the routing table. Now normally what happens when this user asks to reach to this server, this router used to make a request to the nearest router. Now if this router makes a first request to over here or go through the routing table and think that this router might be able to help this router in order to give the information to this workstation, then this router again is trying to reach to this destination via certain routing table itself. That means they all are sharing the common thing, that is their routing table. And there is another one thing, this router might be having the connection to this router also physically straight away. For example, it might be a virtual world also. Now that means this router can make its own decision sometime that if I go through this road, though we have a routing protocol, a routing table is there, it might take a little bit longer. And if I go from this router to straight away to this router, then I can ask for the help to this router, since this router already has shared the routing table on it, so you can reach over here straight away. That means router can make its own decision as per the distance, as per the size of the packet, as per the protocol they are using over the network. Okay, but here is one thing, they all depend on each other. If any of the router goes down, they will have to find it out some other way. This is your hardware based networking actually, in simple terms. Okay, now they all are going through their routing table and they share with each other. They read, okay, how many hops are there, they will count it, then only they will reach to their destination. So it's going to take time. Obviously it's going to take time, and we all are working in this way only. That's known as a traditional way of routing. All the routers, no matter how many numbers of routers that we all are using over the cloud, they used to share the routing table to each other. That's why whenever you hit any of the website, okay, routers are going to decide through which path you are supposed to be, reach to that destination server. So in that case, these routers are going to help you. This is the normal way, guys. We all work in the terms of this information technology at this moment. In the world of networking, in the world of cloud computing, entire things are working this way. But now we have come to the new option, new technology over here. We call it software defined networking. So how it does, let me explain now. In a software defined networking, when the client computer makes a request actually to reach to any destination, it might be the same over here, this server. Now if we have deployed, or if we are in a part of this implementing software defined network controller, so how is it is going to help you? Let's see now. In this case, if you remember in our previous video over here, all of these routers have their own routing table. That means they all are working smartly. They can make their own decision through which part through which router you are supposed to forward your packet, so that you can reach to your earliest and you can have your safe communication. That means they all are using their own brain to make this precise decision. Okay, now if I come to this option talking about software defined networking, when we use the software defined networking, trust me guys, all of these routers will be acting as a switch only. And I do understand that, I do believe, I mean to say that you all understand the difference between router and the switch. That means now all of these routers in our previous traditional way of working for the routing, these routers were using their own brain. They were making their own decision in order to reach to the destination. If this router finds better way to go through this, it's gonna request to this, it's gonna take time. Now over here also, this router is going to make its own decision. It might be coming through this way or it might be coming through this path. It depends upon the traffic also sometime. Now in that case, if we come up with the software defined networking, what happens now? These routers are not going to work as a router. They are simply going to use as a switch, nothing else. That means their brains will be controlled by this software defined networking. All the routing tables will be controlled by this. That means what is the advantage now? Whenever this computer is asking for the help in order to reach to this server, now what happens? This software defined networking controller has the detailed information of all these devices, all the routers. That means this software defined networking knows the exact path through which you are supposed to be forwarded to reach to your destination. So it's going to work as a brain actually. It's going to control the entire flow of the traffic actually. So this software defined networking is going to control all of these routers. That means you don't have to depend on these routers anymore. Now entire routers tables are going to be controlled by this software defined networking. So if we work this way, what are the advantages? Let's see now. If I talk about the advantages, first one is the faster processing. In what sense? When you were using the traditional way of routing, this computer makes a request to this router, then this router tries to contact to this next router, it reads the routing table, and this router trying to make a contact to at the same time to the next router and reach the routing table. No matter which path you use, definitely it's going to take time because you'll have to read the path. That means the routing table has to be studied properly. Now that solution is done over here because all of these routers routing table are being controlled by this software defined networking. That means your communication will be done faster rather than asking to router 1, router 2, 3, 4. This computer after this router straight away it go to the SDN and then it will help you to reach to your destination. That means the communication speed is going to be, trust me guys, faster and faster. And the next example, that means the next advantage is that SDN monitors every router. That means whatever routing tables are changed over here by the time you had a connection, all of these routing tables are going to be monitored only by this SDN. That means you don't have to worry about the routers. That means it is managed in centralized way. So it's gonna save your time, the communication is done faster, and it's gonna monitor your all the routers as well. And the next one is that reduce the cost of expensive routers. If you remember, in a traditional way of routing over the cloud, or it might be in your physical setup also, there are so many routers in order to forward the packet, in order to work as a routing protocol over here. It's going to route over here, it's going to route here, it's going to route here. And don't forget, if we talk about the routers, they are quite expensive. So if I work on this software defined network, what's going to happen over here? If you see, software defined networking controller is going to act as the brain of all of these routers. Most probably we don't need the router. It works as a switches only now, because all the routing table is to be controlled by this SDN. So that's why it's going to be less expensive. That means the cost of router will be reduced definitely. Okay, and now apart from that, if you see this point over here, reduce the time for each router's configuration. For example, let's say you are having 6 routers over here. Okay, and you add another one router over here. For example, you added another one router over here. And you need to set a communication with all of these routers, and the routing table is to be updated over here, and the manually routing command has to be typed in the new router also, and that work is not needed to be done. That means that configuration time will be saved actually. Otherwise, if you see over here how many routers you are supposed to configure, if I add one more router over here, that means 7 routers routing table you are supposed to configure one by one. So definitely it's going to take time. So that's why if we go for the software defined networking rather than a hardware defined networking in terms of forwarding your packet with the help of the router and the routing protocol, so definitely it's going to reduce the time for each router's configuration. Okay, but if I talk about the entire architecture of your SDN, it's actually divided into 3 layers. The first one is your forwarding layer. Forwarding layer means if you study this image over here, every time all of these routers routing tables are updated to each other. That means no matter, even if you are using SDN control over here, the routing table is to be controlled by this automatically. That means the routing information is here actually. So in that case, software defined network controller itself work as your forwarding layer. That means all of these routers forwarding work is controlled by the SDN only. Now, since the SDN does all of this work over here, that we call a forwarding layer, now SDN control layer is over here. SDN control layer means all of these routers forwarding layer is controlled by this SDN, your controller. All of these routers are controlled by this. And what about the mechanism or the program that's going to help you to control all of this forwarding? Because this SDN controller itself is not going to do anything until and unless you have certain application that is being programmed to do so. That means in software defined networking, there is an application that is going to control the entire forwarding layer over here. And that is done by the application layer. That means application layer is installed itself in SDN. So below the SDN, you will find the application layer. That means with the help of this application layer, with the help of this application only, this forwarding layer and control layer is going to function. That means with the help of your application only, the forwarding will be controlled. But there is one problem. There is a big problem. Let's see now. This router that is being used in your network, it might be from the Cisco. This router you are using over here in a network in order to work with the software defined networking to forward the packet to the particular destination, reducing your time speed. In that case, this router might be from the different company. And this router that was the third or fourth router, this might be from someone else, another company. So in that case, you will have the problem something like this. Let's say this is a one guy who can understand only Chinese language, for example. And here is someone in Indian dress can understand only Indian language. And here someone looks like from a, African country can understand only their language. So how do you think this guy is going to help them to communicate with each other? Because they should have common set of rules. They should have a common set of protocol actually. See again, if this router is being controlled by SDN, okay, but this router is from the Cisco. They have their own set of this protocol, own set of rules they might be having in order to communicate with each other. That might not be read or understood by the Juniper router. So similarly, we are having same problem over here now. See, they cannot understand to each other. They cannot talk to each other because they all are using the different language, different protocols they all are using. Now, how do you think this traffic police or this translator is going to help you to communicate? So in that case, we are going to use a new type of protocol now that we call open flow protocol. That means in every device, Cisco, Juniper, MikroTik, for example, all of these routers are going to have an open flow protocol. This will be now next generation's very widely used protocol in order to communicate between different protocols over the cloud, so that your SDN project becomes successful actually. Now, if we talk about the implementation of this software, I mean to say this software defined networking, for that open flow protocol is mandatory. Without this, trust me guys, your software defined networking cannot be implemented. Why? Because two different hardwares, two different routers might be using different protocol. In that case, the software that we are talking about, the application level that we are talking about, they will not be able to communicate with each other. So that means now here comes the necessity of one new protocol. So that we call open flow protocol. That allows the server to instruct network switches. Remember I told you now no more routers, might be only the switches. So it helps you, okay, it allows the server to instruct the network switches where to send packets now. That means straight away it will take you to your destination. So all the packet forwarding, all the routing is going to be decided by your open flow protocol. That means in order to work properly with the help of your software defined networking in your network, you need to have this protocol. We call it open flow protocol. Okay, so that was a brief introduction actually. What is the meaning of software defined networking and why do you think that the open flow protocol is needed? I guess I made it clear that this protocol is mandatory now. So I hope it was a brief introductory to you all in order to understand the necessity of software defined networking over the traditional way of your hardware defined networking and all the advantages as I showed you. I hope it made it clear. If you find it fruitful, please do like and subscribe. Thank you.